Hello everyone, today I want to talk about how I made the various custom rainbow related actors for my latest Super Mario Bros. Wonder level. That includes the actual rotating rainbow arches, destroyable blocks that are slightly curved to allow them to form the same kind of shape, neon rainbowy spike arches, and decorative rainbows that are used in the level's background. And despite how basic some of these actors might seem, you'd be surprised to learn just how much trial and error went into the creation of most of these. The idea of hollow rainbow rolling hills first came to me around 5 years ago, after making this custom New Super Mario Bros. U level that featured rolling rainbows that were simply remodels of normal solid rolling hills. And with my newfound ability to make basically fully custom Wonder mechanics, I recently decided to finally give this idea a shot. Now, given I'm about to describe the extremely tedious process of creating all of this stuff from scratch basically, you might wonder why I didn't just make this gimmick a simple remodel of the original game's rotating dragon fossil actors. That's because before I even started working on the rainbows, I'd already decided the level I was going to make with them was going to incorporate destroyable blocks that could seamlessly be made a part of the rainbow structures. And being able to fit these blocks and rainbow pieces together perfectly like this required very precise shaping that simply wouldn't be possible using actors that were never designed with this purpose in mind. So I started working on my rainbow arches from scratch. There were quite a number of factors that led me to deciding to make the rainbows the size they ended up being. The player needed to be able to fit inside the rainbows, even as an elephant, without getting crushed, even if there was a block in the middle. And I also wanted its shape to be easily dividable into a number of square-ish chunks, which is what I'd use as a basis for the size and shape of the destroyable blocks. So after a lot of finagling, I ended up settling on this shape, which is a circle with a radius that ranges from 3.5 to 4.5 tiles, which can be divided into 24 identical, relatively square chunks. The dragon fossils use a separate collision file of a type that we don't know how to edit quite yet, so for the collision of my rainbows I was gonna have to figure out my own method. As I explained in my custom lava slope creation video, Super Mario Bros. Wonder features a pretty handy collision shape called Polytope, which consists of a list of grid points that the game connects to turn into a solid shape. So the idea was that I could copy over the coordinates of all of the points that made up this model into a polytope file, and that would make a perfect replica of this shape as collision the player could actually interact with. However, if you remember that lava slope video, you might already realize what I was forgetting at this point. This collision type works by connecting every point to every other point, meaning it's impossible to make concave shapes, such as an arch, because the game has no way of knowing that these points shouldn't be connected. When running into this same issue for the lava slopes, I solved the problem by splitting the collision into multiple polytopes that divided the points that would otherwise cause unwanted connections. But in the case of this shape, the only way I could split things up to avoid the problem entirely was by making each polygon its own polytope, and the full circle was made up of 192 polygons. Not only would implementing this probably require hours of manual work, but I'm honestly not sure if Wonder could even handle dealing with like 1,000 collision shapes being loaded at the same time. So I ended up having to go for a bit of a compromise by using a lower poly circle as a basis for the collision, while still using the original circle for the model. This meant each block-sized chunk of a rainbow arch is only made up of 2 edges, meaning the curve isn't super smooth, but I honestly think this ended up being basically impossible to notice in-game. And still, in the case of the biggest rainbow arch type, implementing 40 or so separate polytopes by manually copying over 4 sets of coordinates for each one took a lot of time, so I'm happy I didn't commit to a higher fidelity shape. After implementing the collision, I did discover one downside to polytopes that I wasn't aware of beforehand, which is that you can't wall jump off of them. However, I don't think most people would intuitively think to wall jump off of rounded shapes like these anyways, and I designed the level to where this is rarely something that would actually help the player progress. Even though you've seen me work with this fully circular rainbow shape so far, I didn't end up creating an entirely enclosed rainbow rolling hill actor, since the only way to tell what direction the rainbow arches are rotating is by looking at their edges, meaning it would be impossible to tell how or if a full rainbow circle is rotating. Overall, the Gimmicks visuals were mostly inspired by the rainbow structures that appear in a level in New Super Luigi U, so the textures are extremely straightforward. It's a simple rainbow gradient with flat sides and bolts on the edges. It's a far cry from the more realistic translucent rainbow look I went for in the New Super Mario Bros. U iteration of the gimmick, but I always felt like those didn't really look like they should be solid, whereas these do. Anyways, that's pretty much everything about the creation of the rainbow arches covered, so let's move on to the rainbow blocks. Well, I call them rainbow blocks. As you can see, the final version hasn't ended up looking super rainbowy, and that's for a good reason that we'll get into in a bit. But first, as you probably figured, I made the model and collision for these blocks in exactly the same way as the rainbow arches. My original plan for this level involved using the colorful sugar blocks that appear in the original game, however the color of each of those blocks depends on their positioning on the level grid, meaning they'll change colors when moved. This is kind of a cool and unique effect, but I don't think this would have looked good with how I was planning on using the rotating blocks throughout the level, so I decided not to use the sugar blocks after all. Instead, my second idea for the blocks was that they'd be a kind of pinkish neon with a rainbow gradient. That way they'd fit the level's rainbow aesthetic, but I could also make them use the pink particles that the original game's coral blocks spawn when they're destroyed. However, I was surprised to discover that destroying these blocks while they're rotated results in this rotation being applied to some of the destruction particles, meaning they fall upwards. Thankfully, I realized that although this problem is present for pretty much all of the destroyable blocks in the original game, the same isn't the case for the particles spawned by the carryable pots. Now, of course, I didn't want my rainbow blocks to be carryable or have gravity or anything, but that didn't mean I couldn't use the pot's particles, because as I recently discovered, swapping the destruction particles of any given Wonder Actor is as simple as renaming its E-Link reference. The only issue was that now the destruction particles of my rainbow blocks weren't particularly rainbowy anymore, which is why I ended up having to settle for this more brown and yellowish design. I don't like this look as much as my original plan for the blocks, but it's fine, I suppose. The final rainbow arch related thing I came up with was curved neon rainbowy spikes. These originally only came in 1x1 pieces, just like the destroyable blocks, though after it became clear to me just how many spiky rainbows the level would feature, I also made larger sets, including a full rolling hill variant. And in terms of actor setup, the spikes are identical to the normal rainbows, I just changed the collision type to one that damages the players. So the only truly unique thing about the spikes is their visuals. The original game's generic 4-directional spikes feature an animation where individual spikes extend and retract, which the game actually alternates between for every spike actor in a checkerboard grid pattern. The reason this animation looks a bit choppy is because instead of being a 3D modeled skeletal animation, it consists of a set of animated textures made up of 16 frames that get looped every second or so. Now, I was originally planning on getting rid of this type of animation for the spike arches, but I was also kinda struggling to come up with a way of making the spikes look rainbowy whilst keeping their traditional metallic look. And then I realized the animation was the answer to that, because on top of the positioning of the individual spikes, I could also change their color each frame. So I started by making a custom 2-sided spike strip texture, including a normal map and mix 0 texture. Then I made 7 additional variations of all of those textures where each spike incrementally retracts and then extends again, or vice versa, and the color of all of the spikes shifts 1/8 of the color spectrum. And then finally I duplicated all of those textures to make a sheet of 16 frames in total. The reason I repeated the animation once in a loop, instead of making 16 unique frames, is because of the animation checkerboarding I mentioned earlier. Basically every other spike actor placed in a row has this seemingly hard-coded property where its animation is offset by 8 frames compared to the neighboring spikes. But that property wouldn't make sense for the way I'd designed my spikes, so making the animation of my spikes loop halfway through meant every spike actor looks the same no matter if it has the offset or not. And that's all of the level's physical mechanic stuff covered, so all that's left for me to explain is how I made this simple decorative rainbow asset for the level's background. If you watched my magnet creation video, you may remember that in order to make those animated magnet beams, I edited a rainbow actor that appears in the original game. So my original plan was to make a duplicate of the same actor and edit it to complete the rainbow arc, which should be pretty easy. So I swapped the vanilla rainbow's main model and texture whilst keeping its sparkly animation intact, checked it out in game, and at first glance, sure, that looks pretty good. But look a bit closer, do you notice anything? A lot of video games, including Super Mario Bros. Wonder, struggle rendering one translucent material through another translucent material. Because as far as I understand, it's unintuitive and costly for a rendering pipeline to layer multiple materials that are a part of different models on top of each other whilst rendering all of them properly. And this same problem is clearly present here, because even though this rainbow is placed behind these clouds, the clouds' soft translucent edges are rendered behind the rainbow. I was aware of this problem when it came to looking at the clouds through water, but didn't realize the same could apply to just about any see-through material. Now, at this point, I made a bit of a mistake, because instead of messing around with this problem some more and performing tests to see what exactly caused this, I jumped to a conclusion quite quickly that turned out to be incorrect. See, I remembered that the original game features several translucent background elements that properly render in front of or behind clouds, such as this streak of light that appears in one of the desert backgrounds. What's different about the material of this asset compared to my rainbow is that it's basically completely made up of vertex colors instead of textures. I've talked about vertex colors before in that same lava slope video I mentioned earlier. They're a way of indicating the position of gradients along a 3D model by applying color values to each vertex, and in the case of the material used by this light streak, those colors indicate the translucency of this light effect. So since at this point I was under the assumption that it was this material type that allowed for the translucency layering problem to be fixed, I decided to make a new rainbow entirely out of vertex color gradients. The actual color of this light streak is determined by a separate material value, meaning it can't normally consist of multiple colors, so I had to split my rainbow into 7 separate models, each made up of one of the 7 rainbow colors, which fade in and out on top of each other based on the vertex color gradients. It's hard for me to overstate just how much trial and error went into trying to make this look good, because it was really hard for me to make what looks to be a continuous solid gradient out of 7 overlapping meshes. But I think the resulting asset ended up looking even better than the texture version of the rainbow. However, as I've already teased, this didn't solve the overlapping translucency problem. That ended up being just as present as ever. You know how in some of my videos I've talked about running into issues that were so perplexing or devastating that I considered giving up on the whole underlying idea? Well, this was one of those. I had no idea what was causing this problem for my custom actors when the vanilla actors handled layered see-through effects just fine. And you know what the funny thing is? I never figured out what causes this issue. That might sound impossible, after all I did actually fix the problem, but not in a way that was actually derived from finding out what caused it. Let me explain what I mean by going through another problem with this same actor. It's been a known fact in the Wonder modding community for some time now that it's currently impossible to make a duplicate of a background actor without that actor for some reason losing its ability to be placed in the background. Even though putting a vanilla Wonder actor on the background layer normally logically places that actor in the background, this just doesn't happen for custom actor duplicates. This means the game can somehow distinguish between vanilla actors and custom actors, even though in pretty much every way except this one they get treated the same. There's probably some kind of internal list or set of properties that we don't know of that could be edited to give custom actors all the functionality of normal ones, but until we find where those parameters are stored, the only way to make custom background assets is by straight up replacing the vanilla game's assets. And looping back to the translucency layering problem, this turned out to be the exact same type of thing. For some annoying reason, this problem isn't present for vanilla actors, but appears by default for any actor duplicates. So the semi-solution ended up being as simple as editing one of the original game's translucent background actors to make it load my rainbow model instead of loading it through a custom actor. And I still can't tell you why. Anyways, that confusing and kinda frustrating note marks the end of what I wanted to talk about for this video. Even if making the custom actors took a lot more work than I had originally imagined, I'm very happy that I finally managed to make this idea a reality. As always, if you have any suggestions for ways I might be able to turn the original game's actors into something more cool and custom, please let me know by leaving a comment. While you're down there, maybe also consider leaving a like, subscribing, checking out my Discord server linked in the description, or signing up for a YouTube channel membership. Thank you so much for watching, and bye bye!